And we want to automate the loading of a site-specific configuration onto those devices in an automated fashion and testing it all during the engineering visit. So that's the plan. So this is how we did it. This worked. Prior to migration, so we're talking in the weeks, days in advance, we've got our wide area network. That's where we want to migrate our sites to. Yeah. We've got some data centers. Let's not worry too much about them. That's where the sites need to get to. And then we've now got an access layer. So this is effectively an extension of our WAN. So this is maybe a particular use case which won't be applicable to all of you. But here we've got an access network which is being used to connect into our wide area network. And here we're talking about DSL, but it could be VSAT or anything basically which uses PPP, the point-to-point protocol for connecting between the remote sites, which I haven't shown yet. They'll appear up on the top left here, through to our NNI. Why is PPP important? Well, we'll see that later on. Okay, so if this was MPLS attached sites, maybe what I'm describing to you isn't necessarily going to work, because with MPLS, typically you need to have specific IP addresses configured straight out off the bat to get your connections up on BGP peer statements. So, okay, so also prior to migration, the customer is going to give us a load of information, aren't they? So imagine 12,000 rows here. I'm just showing you 3. So the customers give us information on the site ID. There's always a site ID, isn't there? Postal addresses, and then we've got site specifics. Now, I'm just showing you examples of IP addresses of site specifics, but it could be unique interface configurations, things that we've agreed with our customer that need to be in the site-specific configuration. So it's like the minimum that we're going to need to generate the site-specific configurations. And now we move on to generating those site-specific configurations. Now this could be done in advance, or even better, do it at the moment you actually apply the configuration. Okay, so how are you going to do that? Well, lab testing, you're testing in proof of concept, you're making sure that different configs are actually going to work. I won't go into that today, I'm sure we're all very familiar with that as network engineers. So we have these site-specific configurations, and we've got a management network. We always have a management network running our wide area network, and within there we've got a Unix server. Okay, and I'm calling it the Unix script server. And we're going to load all of those configurations on there, or have a script that's capable of generating the config from templates combined with the site-specific information. So the little table on the right there is representing the little grey square is the config for site 11111, and there's another config ready to apply for site 22222. Okay, with me so far? Also prior to migration, we've now got our staging center, or could be staging centers around the world, and it's got a whole bunch of routers in this case, and it could be some switches as well. They've been purchased from the vendor, and they are loaded up with an identical configuration. So we're meeting our first criteria, which is an identical configuration on all equipment, and we'll talk about what that configuration has to contain to make this work in a minute. But the point is, it's all identical equipment. Okay, we've now moved to migration day. So this is the morning of the trip, of the installation. So a bunch of routers are thrown into the back of the van, and it doesn't matter which ones they are. Or it could be couriered the night before to the field engineer going out to wherever it is. And the van drives off and turns up at one of our remote sites. Okay, so now finally we see one of those remote sites. So you can see there's an existing router, which I've shown in yellow to differentiate it from all of our company's devices. And we've got some customer equipment connecting in through the LANs. And what happens is the existing router is removed by the engineer, and one of our devices is installed in its place, okay? And you can see it's got a serial number on the router, and in the case of Cisco, that's printed on the underside of the router. I'm sure that's the case with all the other vendors. And so now what happens? Well, this is where the configuration using PPP comes into play. So it's powered up, and without the on-site engineer having to do anything, because of the base configuration, a PPP tunnel is built through to our NNI. Okay? And we'll have a look at some of the config needed to make all of this work in a second. The router authenticates itself by virtue of the fact that PPP has that concept, maybe involving a radius server to verify the credentials. But remember, there are identical credentials here for all of the remote sites because they've got the same config. And by virtue of the fact that PPP has a concept of negotiated IP address allocation, an IP address is allocated to the remote end router from a pool that is owned by the NNI router. There could be several NNI routers, each with their own pools, but we know that the remote site equipment is going to get an IP address. And the key thing here is you can have multiple routers up at the same time, all being allocated dynamically an IP address from the pool. Okay? That was one of the key things we tested early on to make sure that this was really going to work, that you could have multiple sites in that initial state. So now this has happened, the remote site router has got an IP address, and we're going to be able to ping it. You can probably guess what's going to happen next. We've got some real people involved here. Our commissioning desk staff is not all without human intervention, and they're going to connect in via the corporate network to our Linux server. And they're going to be executing a script which will show them effectively information like this: one IP address, serial numbers, postal addresses, site IDs. So the script on the Linux server is continually, without any intervention, polling the pools of addresses that the NNIs are allocating to the remote sites to basically discover them. Yeah? So this is happening maybe every 5 minutes. And sooner or later, routers are going to start being discovered because they're being installed on that morning by the field engineers installing them. Yeah? And when a ping is responded to, the script then uses SNMP to go into the router or whatever and say, what is your serial number? Okay? And I'll show you the command to do that if you're interested in the OID, but you can just Google it. So now we can present to our commissioning desk staff the serial number that's been discovered and also this pool IP address, this temporary IP address. Okay? But we don't know where this router is at the moment. We don't know which of our configs to put out there yet. Yeah? So the next thing that happens is the field engineer phones in to our commissioning desk and says, hey, I'm at site ID 1111 in this case, and I have just installed the Cisco router whose serial number is GR12345667, because they read it off the bottom of the router. So foolproof, yeah? So you now know, as the commissioning desk staff, you know where that router is. And you're going to know which configuration is got to be generated and sent out to it. Okay? So, but at one stage we thought, well, shall we give the engineer a portal so they can enter this in themselves? That would be nice, wouldn't it? Trouble is then you've got to have internet access for your engineer. You've got to train them on using the portal. So just use the phone. Phone up our commissioning desk and tell them these two key facts: the serial number and the site ID you're at. Okay? So now the commissioning desk staff can just use another script that I wrote with my team and entering in the two key values, the site ID and the serial number. And so that's populated, and hence you can see we now know which config to push out there. This is the site-specific config with all of the site specifics. And then the script just takes over. We push via SCP, I'll show you the command to do that, the config to the startup config of the router, and we reload it. It takes a few minutes for the router to reload. You think, well, Matthew, why don't you just tinker around and edit the running config? It's much cleaner and safer, really, if you push it to the startup config and reload, because then you've got a nice clean router coming up with a completely new build, a completely new configuration. So now, having after gone through that step, the router is going to come up with its specific configuration, unique interface features, IP addressing, host name, all the security parameters. It's got its final configuration. And any sort of backup technology, a second DSL link, 3G, 4G radio in this example, VSAT, that's all going to come up now. And nobody's done anything to make this happen, yeah, other than plugging it in and the commissioning desk entering in a one-line command. This is automated. And then the script server can finish up and log in to the remote site router and do any testing that you want, pinging over the backup link, over the primary link, clearing interfaces, looking for interface errors, all of that sort of thing. And that's it. Basically, the site is now live. So watch closely the commissioning desk person there. As the van drives off and he waves. You see that? I'll be doing a special presentation on how to get that person to do that. Because they're all such good friends together. So, and they can go off and do the next site, you know, maybe multiple sites that day. So that's basically the approach we took. The rest of the presentation just talks about some technical details on how to do some of this stuff, which I'm also sharing via my GitHub account. So here are the Linux scripts. So you need a scheduled script, which is running every 5 minutes or so to discover the sites. That was, in this case, written in Bash and using SNMP to get the serial number. And then we need some triggered script that does all of the following things. Firstly, generating the config. We all know how to do things like that, merging with templates to generate site-specific configs. Doing it on the fly means that if you hit bugs during your rollout, you can edit your templates, and you know, going forward, you're improving, getting where you want to be with your final configs. Put it that way. Pre-site checks, so you might want to do all sorts of checks around, you know, has this router really got the right OS, the right build, making sure that its new config we're about to apply isn't live. We don't want to accidentally put the wrong site ID in and push a config out to a new site which is already running. That would be a bad idea. So now, just a word on expect here. Just before the meeting, I was asking a few people how many people have come across a program called expect or pexpect. Can I just have a show of hands? How many of you sort of programmed in expect or pexpect? So about half of you. Okay, I'll just mention it quickly then. The thing about expect is the clues in the name, as Paul said before the meeting. It's a programming language that allows you to spawn the term is spawn, a telnet or an SSH or an SCP connection, send a string of characters like passwords or logon credentials or show commands, whatever you want, down the line, and then wait for a response to come back. And the code can fork depending on what comes back. Now, the advantage of this approach is it makes for a very robust interaction over potentially an unreliable network, so that you know that the commands have actually been taken and acknowledged, or not, as the case may be. I've seen some online examples of interacting with routers where the person is sending some configuration, then just waiting a timer, and kind of assuming that the commands have got there. That's maybe not, in a production environment, not such a good idea. There's also, those of you who are Python programmers, there's pexpect, which is basically the same thing. And you can just incorporate expect type of commands, which I'll show you some examples of in a minute, into your Python code. Also, this second script is going to copy the config across. I'm using SCP. And reloading, again using expect. And finally doing some tests. So we've got some bash code and using expect just to interact with the device for show commands and checking what the response is, making sure it's as expected. Okay, so finally we've got a few slides just showing some key configuration for those of you who haven't come across this stuff before. The first one is a bash command for getting the serial number. Instead of using SNMP walk, we've got a community string, IP address, and there's the OID. That'll give you the serial number. at least for modern Cisco devices. Then we've got an example of expect code to log into a router. You can see the shebang here is telling Linux that this is our expect. This is you're going to use our expect library. That may depend, or the path there may vary on your environment. We're setting some parameters, but you can see. Remember, I said it's called spawn. In expect, we're going to spawn SSH and send some commands, and then we can expect various things to come back, as I was describing before. And we can have a default. If none of these things come back, then the default will be that maybe we kill off our spawned process. We're going to kill off that socket. This is going to lead to very robust little modules that then you can use in Python and expect to interact reliably. Obviously, things like Ansible have got. So you have a question?
So you've got a typo there, password, haven't you?
Beg your pardon?
Typo on password. The word password, the expression password, you've got an extra S.
I have. I can see that. That wouldn't have worked. So why can I never log on? Yeah, no, thank you for pointing that out. I'll correct that on my GitHub version. We can kill off the socket and make for a very robust connection another little bit of expect code here for reading in a bunch of commands and applying them. Now, things like Ansible have got this built into various modules. So that's the approach, and I'll talk about Ansible in a minute. And also, expect has a concept of a buffer, which can be read out to a file, so you can look at the responses coming back and have your Python script that's using this expect code to do various things depending on the responses. And finally, in expect, this is a little bit of code for doing our SCP connection to push the file out to our startup configuration. Okay, so all of this stuff is in my GitHub account for anyone who's interested, and this stuff works. Got the right number of S's in this one. Okay. Okay, so we spend a lot of time talking in these meetings about Ansible. And hardly surprising, because scripting is a very powerful thing. You can, if it goes wrong, you can create a lot of damage very quickly, or if someone's malicious, they can cause a lot of damage very quickly. And Ansible, and certainly Ansible Tower, the sort of the GUI overlay of Ansible, gives you a huge amount of governance and control. It integrates nicely with GitHub for version control on playbooks, pushing things out. So if we can use Ansible to do these sort of things, that would be good. So I have actually spent a bit of time trying to transpose what I've described to you to Ansible. And some of the challenges I've come across, although I'm slowly getting there, is using native Ansible is that, as you can see, there's quite a need in what I'm doing to have quite complex logic and string manipulation, which in my experience at Ansible is proving a little bit of a challenge. So, but I haven't given up. Perhaps another approach would be to use Ansible to use some of the scripts that I've described to you, such that you've got the governance and control of Ansible, but the flexibility of scripts. Or maybe the best approach, and the pure Ansible approach, would be for someone, me or somebody, to write a module to do the specific things that we're trying to do here, such that Ansible maintains its factual database of the configuration of our entire network, which is what Ansible is all about, running your network as software. Okay, so that's something that I'm continuing to pursue. Finally, last couple of slides now. Here's some of the configuration for your routers to make your PPP address negotiation work. So here, in this case, we've got a physical DSL link. You can see we're linking a dialer pool to it, and that is associated with the dialer interface, and the key command here, IP address negotiated. That's going to mean that the IP address is negotiated. And then at the core end, on our NNI router, remember that's the one with the pool of IP addresses, we're using AAA to authenticate the PPP and realize that it's running the initial configuration. VPDN to hook up to a virtual template. So as each of these connections comes in from these initial router configs, it is associated with a new instance of this virtual interface. And here, the key command in red, here, that's the far end IP address. The default behavior is to use our pool. Okay? And that's going to give you an IP address out of your pool. And you can define the from and to range for your pool, have a couple of hundred addresses in there, and then that's going to give you your pool of addresses which are dynamically allocated. Okay, so this presentation is on my GitHub account, which is there. Matt Taylor, so it's 3 teams together. 5060 is the port for SIP, because I'm also into my call managers. Number was free. And also feel free to reach out to me on my email account. As I say, I'm an independent consultant, so I'd love to talk to you if you want some guidance of how to, basically the approach to doing something like this on this scale. So maybe I could just help you with your approach, or maybe help you, get some code written. And so that's it. Any quick questions? I think we'll also have time for some questions after both presentations when we've got a panel. But any quick questions at this stage?